Hello, welcome back. All right, so still on the discovery of subatomic particles, we actually talked about J.J. Thomson's discovery of electron using the gas discharge tube, okay, or cathode ray tube, and we also, okay, discovered that he wasn't able to, that J.J. Thomson was not able to get the actual mass of the electron. He only uh, he only calculated, his experiment only calculated the charge to mass ratio. So in an attempt to actually get the actual mass, actual charge of the electron, okay, which we know that electron is negatively charged, another experiment was conducted, okay, and this experiment is mostly oil drop experiment. So now this is just a simple schematic diagram of the setup of the oil drop experiment. Okay, so now there are the oil and not oil, okay, is actually being poured into a chamber. All right, and it is actually ionized in this chamber. Now how is the oil ionized? Now X-ray was X-ray was bombarded, okay, into the air in this chamber, okay. Now, of course, the chamber actually contains air. Then X-ray was actually bombarded into it. Now, the bombardment of this X-ray into the air found in this chamber actually causes the air to be ionized. So now, as the air molecules are ionized, now the molecules of the air now collides with the uh, oil droplet molecule, which actually causes the the collision of the ionized air to also cause to make the oil drop, okay, to also be ionized. So you have a chamber that is actually made up of ionized ion. Now a small hole was actually made, okay, so that the ion is going to drop into another chamber. Now this chamber is actually a chamber that is supplied with an electric field, right? Okay, already this ion is ionized and it is actually entering into an electric field chamber. And you know that an ionized ion will definitely have a charge, right? Good. So now the ionized ion is meant to enter into a chamber of an electric field, a chamber of electric field. So what is the whole idea? Gravity will actually cause this oil, once it is leaked through this hole, to fall, okay. And without the electric field, the oil normal direction of motion is that it's going to fall to the floor of the chamber, okay. But by the application of this electric field supplied by a voltage, and of course increasing the voltage to some amount, will actually cause some of this oil, okay, to not to move, to stop at possibly at the middle of the chamber, and to be at equilibrium. So this ionized oil drop that was originally falling due to gravity, okay, was actually stopped to be at equilibrium by the application of a substantial amount, okay, of electric field. So what is the idea of this now? It simply means that the force of, which of course is force due to the weight of the magnet, the force due to the weight of the oil drop is actually balanced by the force due to the electric field that is actually supplied. Okay, so weight actually balances with electric field. Now so we are going to actually establish relationship. Okay, so now the weight of the oil was actually balanced by the electric field by the electric field that is actually supplied. Okay, so we know that weight as a result of gravity, of course, weight is actually a gravity that is given by mg, right? And the force due to electric field, of course, you know in physics, force electric field is always given as force per unit charge. Okay, so that means the force due to electric field is going to be equal to electric field multiplied by the charge, and of course this charge is the charge of the electron, so that's going to give us electric field that was supplied. Of course, this electric field is measurable. Mostly was able to measure the electric field that he supplied. Okay, the mass of the oil was also measured. Of course, G is a constant, which is acceleration due to gravity. So from this relationship, now he was able to uh, calculate the actual charge of the electron. Okay, so which of course is by the formula by the formula from this, the mass of the oil drop, okay, then divided by the electric field. Now the question is, what relationship has the oil drop got to do with electron? Now it is going to be a simple answer. For an oil to be ionized in such a way that it's actually charged, okay, the only thing that actually happens there, it is only the only thing that carries charge in any matter is the electron. Okay, is the electron. So definitely the ionization of this ion is such that it carries a negative charge. So since it is a negative charge, the oil carry, and in an oil, the only particle that has negative charge is electron. So being able to calculate the charge, okay, of that oil based on the electric field that was supplied. So he was able to actually estimate the or to get the actual charge of the electron, which of course is approximately 1.6 times 10 raised to the power of minus 19. This is also the charge of the electron. This is also equal to the charge of the proton. 1.6 times 10 raised to the power of minus 19. The reason why this the charge of electron is equal to the charge of proton is this: an atom in general is neutral. Okay, an atom is neutral. So the only way an atom can be neutral is the reason why we can say that an atom is neutral is if the negative charge of the atom, which of course is the charge of the electron, is equal to positive charge of the atom. All right, because the only charge carriers in an atom is electron and proton. So if atom is neutral, it simply means that the electron, which is negatively charged, must be equal to the proton, which is positively charged. By the time you add the two, it will eventually give you zero. So atom is neutral, okay, because it has equal and opposite amount of charge of proton and neutron. So I hope that is well understood. All right, so we proceed. All right, Rutherford experiment. Rutherford experiment. Okay, so now we are still trying to look at a scientist that contributed to the development of atomic structure. Okay, now another person is Rutherford experiment. He actually conducted an experiment that helped him to discover that an atom has the central core or the nucleus where the mass of the atom is actually concentrated. So how did he do that? Okay, so as you can see in this setup, he actually set up a system, okay, where he bombarded a, a tin gold foil, with alpha particle. Of course, the alpha particle is this radiation alpha particle, so he bombarded it. So now The idea is to know exactly the deviation, or probably to know the characteristics of the particle that passes through the gold foil. Okay, so now after he bombarded it, he wanted to actually monitor what happens to the particles. Okay, that actually reaches the gold foil. So he connected a V microscope that can be rotated, so that he can be able to see if the rays of the alpha particle actually reflected or deviated. Okay, so now this is exactly what he did. So, and this particular microscope is actually connected to a screen. The screen is where the image, okay, of the alpha particle that probably passes through the gold foil, or the one that actually reflected back, is actually produced. So he was able to monitor the different angle through which this rays, alpha ray, actually got deviated. So what did he find out? Okay, now from this diagram here, we can actually get to know exactly what he actually found out. Now he discovered that some of the rays actually passes through the gold foil undeviated. Okay, while some of them actually got deviated, some actually returns back, right, and while some actually got deviated at different angle. So what was his conclusion? His conclusion is that for those ray, the one that actually returns back must have actually encountered in that go for possibly an opposite charge. Why? Because alpha particle we must have encountered the same charge. Okay, alpha particle we know is actually positively charged, right? Okay, so now if that being the case, he was able to discover that, okay, gold foil, which he contains thousands or even millions of atoms, all right, actually has a space. The atoms of this gold foil have space. Now, let me actually, if I should draw that to illustrate, okay, so invariably, if this is the atom, okay, now if the alpha particle actually reaches the nucleus, it is observed to return back or to deviate. But the one that didn't pass through the nucleus, that passes through the empty space, okay, passes through the atoms without returning back. Okay, so from his observation, he was the scientist that actually likened an atom to planet. Okay, he likened an atom to a planet. Of course, in planet we have the sun being the central component of this planet. Okay, so Rutherford, okay, actually likened the structure of an atom to be that of a planet. Okay, having the central core that contains that is the core, where the core mass of the atom is concentrated, then having electrons that are actually orbiting around the center. Okay, so he was the first person that actually postulated the model of an atom, theory of atom, that described the electron as planetary. Okay, planetary, call it planetary electron that actually orbit around the nucleus at uh, uh, at a particular energy level, right? So the electron actually revolve around the nucleus. So we call them planetary electron. So while the nucleus is the central core that is actually movable, where the mass of the atom is concentrated, the electron actually revolve around the nucleus. So please take note of that. Now, after his theory, then Bohr now came and actually modified it. So the reason why his theory was actually modified as this. He believed that an atom, okay, contains the central core having the electron orbiting round the orbiting round it. Now, if this electron is negatively charged, and according to him, this orbiting electron is so actually continuous in movement, in revolution. It doesn't stop. Now, this will not be possible because if this electron is negatively charged, and we know that in the nucleus we have positively charged, there's going to be an attraction, okay? Because positive charge will always attract negatively charged. So there's this tendency that this electron will not be continuous in its movement. Okay, it will not be continuous in its movement. It will actually, the energy, it will keep on being pulled towards the nucleus. The energy will reduce to the point where it actually disappears into the nucleus. But that is not what is actually seen in terms of electron. Okay, so now his story was modified. So according to Bohr actually said that, was able to look at his theory, so that okay, it is actually what he said is correct, that an atom has the central core, right, where the mass of the atom is concentrated. But he said that the energy, electron around the atom has what is known as quantized energy. Quantized energy is that the energy is actually fixed, okay, fixed at some particular specific fixed at specific interval. Okay, of course, if to illustrate what quantization means, okay, let's look at a situation where you have number, you are being asked to count number, okay, you're only counting what is integers. You have 1, 2, 3, 4, 5. That doesn't mean that in between these numbers there are no, okay, decimal numbers. Okay, but in this case you're looking at the interval to be from 1 to 3, 4, 5. Then you are not actually looking at a number being in between this decimal number. So that's exactly what Bohr is talking about. So he's saying that the energy of the electron is actually quantized. So it is actually designated a specific energy, okay, at specific interval. And that interval, there's not going to be any interval other than those intervals. So the energy of electron is actually quantized. And as you can see from this particular diagram, all right, as you can see in this diagram, as you can see, after the nucleus, there is a particular orbit, okay, that contains 2 electrons, okay. Then after that, there are some another space that actually gives another orbit. In between the space of the first orbit and the second orbit, there are no electron, okay. So the electron can only is found in the second orbit, and they are equally. So if I should draw the another orbit, the third orbit, you discover that the spacing is equal at a specific interval of energy level. So that is exactly how Bohr model was able to modify J.J. Thomson atomic model. All right, so we are going to look at other concept of atomic structure in the next video. All right, so see you in the next video. Thank you very much.